welcome to lecture. At this point, you should be moving pretty far into doing your Rice Rock / Asteroids mini project. In this lecture, I'm going to just kind of show you one optional piece that you can add to your game that will improve the visual quality of it quite substantially. I'm going to show you how to do animation inside Simple GUI. It's really fairly simple. We're just going to provide you with a tiled image, and you have to actually move through the image, drawing the various sub-images appropriately. And it adds actually quite a lot of visual impact inside your game. So I'll kind of explain it at a high level, and then we'll look at 2 example pieces of code that'll help you if you decide to implement animations inside your mini project. So let's talk about how a computer game actually animates things. So you've done animation before if you're like most kids. You had a book, you were bored, you started drawing kind of a little small stick figure in the corner of one of the pages, you drew it on the next page and the next page and the next page, and then you flipped through it. And the figure appeared to move. So this kind of perception of motion comes from what's called the persistence of vision. That if your eye actually sees a sequence of kind of discontinuous images, but they actually appear in very fast sequence, your mind perceives continuous motion. This is how movies work. A movie projector projects 24 frames still images a second, but when your eyes see it, your mind processes it, everything appears to be moving continuously. So in a video game, what you're going to have is you're going to have something like this. We have a tiled image here. This is actually 64 images of an asteroid, and it's kind of pictures of an asteroid tumbling. We actually got a lot of them here. We can kind of scroll out and scroll all the way back, and you can see there's lots. And the way we're going to actually animate this asteroid tumbling is we're going to go through and draw this image, then this image, then this image, then this image, all on top of each other. And that's not as hard as you might think. So for example here, we could kind of take this image. Okay, we need to know its center, and we need to know its size. That's what the red box is. And then we want to draw this image. There's its center and its size. We want to draw this image, center and its size. And I think you get the hint here. So the nice thing, all the image sizes for the asteroids are the same. We can kind of look at we basically can look at the image and actually figure out what the size of each of the sub-images is. And we need to know the center. Now the center is not too hard. In this case, this is a horizontally tiled image, so all the vertical positions are the same. So what is this distance here, the distance from here to here? Well, it's the same as the distance from here to here, which is the same as the distance from here to here. And that's just really the horizontal component of this sub-image size. So we have to do a little bit of math to kind of figure out how to compute the centers of each of these sub-images and draw them in quick succession inside the draw handler. So I'm going to show you 2 example pieces of code that will do that. And they'll kind of do 2 different animations. So let's go take a look at those. Okay, let's look at the first example where I'm going to make this asteroid tumble. Let's just run the code to start with so you can kind of see an example of what we might be expecting to see. So here I've actually constructed an animation where we're kind of striding through the image, drawing each of the sub-images at a very slow rate. So we kind of see this kind of choppy ticking motion. So you can notice that actually the images is a .png, so we see kind of a blue background around our asteroid. Now, how do I actually achieve this effect? Well, let's go through and just briefly glance at the code. So the first thing I'm going to point out here is I've actually got some information attached to the rock. I'm not using the image info class. I'm going to let you kind of work with that, give you a little bit of meat to chew on there. The critical thing, notice, is I've loaded the image in here. I have the center, okay, and I have the size. Each of the sub-images is 128 by 128 pixels. That means the center is at 64. And most importantly, there's 64 of these images. So what I've done is I've wrote a little piece of code here in the draw handler that actually kind of does an animation. And it's going to use a global variable time. Now when you implement animation inside your game, you're going to use the Sprite class. You're going to set the animated flag to be true. And you're going to have to use the 2 fields, age and lifespan, to kind of control the animation inside your implementation of the last mini project. So you're going to have to take this and kind of work with it a little bit and kind of integrate it into the Sprite class. So here I have a time, and what I'm doing is in the draw handler, I'm updating the time every time I draw a frame. So I'm updating the time really slowly here, but notice I'm drawing about 60 times a second on my computer here. So what I'm really doing is if you do this 60 times 0.3, it's about 2. So really every second I'm kind of drawing about two images of our sprite. So how do I actually make this work? Well, I go through and I take the time and I do some modular arithmetic. Take it modulo 64, so my number that I'm coming back with is always in the range from 0 to 64. And then I do one thing a little kind of tricky here. Because this number is a fractional number, I don't want to have to actually index by a fraction. I want to index by a whole number. So I'm going to do integer division by 1, and that takes the whole part of the number. So this gives me the index inside the tile image, and now I do my computation of where the center should be. It's the same thing before. We start at the center of the first subimage, we add in the index times, well, this is the size of the rock in the horizontal direction. And notice that the position in the vertical direction stays unchanged. So when we're done, we've actually got the current rock center, we've got the rock center for the where we want to draw it on screen. We always draw it at the same place so it appears it's moving. So we're kind of ready to go here. So let's just do one thing. Let's go through and actually change the value of time. So what I'm going to do next is I'm going to change this to where time is 1. So every time we draw, we stride through this animated asteroid image. So I'm going to go through and make time equal 1. And so let's see what happens. And wow, our asteroid is tumbling very, very fast. Probably not a very realistic animation. So this particular tile image has the property that if we kind of draw it at kind of one draw per frame, it's going to animate much too fast. So we could go back and ask the artist to make us more frames in between, so we get a longer tiled image, or we could basically have it a much shorter animation, or we could go through and kind of slow it down by kind of adjusting this time variable. So what I could do here is I could maybe change it, say 0.2. So if we go through and do that, what you can see now is it's actually tumbling a little slower. So at 0.2, every 5 frames, time goes up by 1. So every frame, we're kind of flipping forward to the next image. So this is really, if we do 5 frames, it takes kind of 5 ticks to do a single frame, and there's 60 ticks in a second. We're kind of doing 12 frames a second in our animation. And that's actually slow enough your eye can actually perceive this kind of jumpiness in there. If we sped this up a little bit, maybe take it to 0.1, let me actually 0.4. I think it'll start to look continuous. Yeah, it's going to start looking continuous here, but the problem is our asteroid is tumbling way too fast. So fundamentally, if we're going to try to animate this tumbling asteroid, we don't have enough art here. We need more frames in our animation to get a really good, realistic looking animation of a tumbling asteroid. Okay, let's look at another example. So let's look at a second example of doing animation. So here I have a kind of slightly modified program. It's loading in a second image. So let's just take a quick peek at the image to get started. So it's a very nice tiled image of an explosion. This explosion was actually computed by a computer program. So, you know, if you go and watch movies a lot, there's a lot of work on computer animation where people use physical simulations to build things that look really cool, and they can look very realistic too. So the way this image is laid out, it's tiled again, and notice here that we have to kind of figure out kind of what order to draw the images in. So we have two possibilities. We could draw kind of left to right and then top to bottom, or top to bottom and then left to right. And I think if you look at the image, it's pretty clear we draw left to right, then top to bottom. So we have to work out a little piece of arithmetic to kind of figure out, as we're kind of cycling through this image, which particular subimage to draw. The other thing to note here is that this image has a lot of detail. The jumps between each of the subimages is not too much. And in fact, because this was created by a computer, this is actually, image was created to be drawn at exactly 60 frames a second. So our clock arithmetic will be a lot easier in there. So let's go back now and look at the code we have. So we kind of load the image here. We have its size. Each of the subimages is 100 by 100. Their centers are at 50-50. The most important thing here is actually we have the size of this image. It's 9 by 9. So there's 9 images horizontally, 9 images vertically. So here's what I was saying, a very similar code we have. We have a timer. The only thing to notice here is our timer is always being updated to web 1. So we're actually going through every frame. We're kind of striding through and drawing the next image inside our subimage inside our image. And that's because this image was created exactly to be drawn at 60 frames a second. The only piece of code that's kind of tricky right here, and this again is using remainders and modular arithmetic and integer division is to actually go through and compute, given the time, kind of what the horizontal index is and what the vertical index is. And that's stored in this tuple here, in this pair. And then we have to go through and actually find the center of the image. So we're striding through this image very quickly. We're going center here, center here, center here, center here, center here, all the way down, then jump back to here, centers through here, jump back to here, and so forth. So it's not too complicated. I think it's something that, given what we've done in the class, you should be able to work out fairly easily. The reality is all the things we're giving you are actually horizontally tiled images, so you don't even have to do this math. I just want to kind of give you a little peek at what you might want to do if you actually had a kind of a 2D tiled image you wanted to animate. So let's just run it. What you can see here is we have a very nice explosion actually. And notice it kind of has kind of the right time here. So again, this was actually computed using a physics simulation so that we would actually see kind of a nice realistic explosion if we animated it exactly at 1 frame per second. So that should give you kind of enough kind of ideas to go out and add animation to your game if you want. You don't have to. I don't think it's that hard if you've got some time. I'd probably allow maybe an hour or 2 hours to kind of put this in. One piece of advice, if your code is working, before you put in animation, absolutely save it. Grab a copy of it so you can always turn it in if it turns out that putting in animation doesn't work out very well. This is kind of always a good piece of advice to programmers. If you've got something working and it kind of satisfies the requirements, set it aside, grab it, hold on to it. That way if you kind of put in some extra bells and whistles, you don't get stuck in a situation where you make a bunch of changes and then you can't recreate something with kind of basic functionality. All right, so I'll be out on the forums kind of monitoring questions about this and other topics related to your last mini projects. So go take a crack at it. I think you'll find that if you put animations in, especially kind of an animated explosion, it'll make your game look really nice.